Alright, everyone. Welcome back to All Night Labs. What is this thing doing right here? What do you think? Green lawn landscapes. I don't like that. Well, welcome to All Night Labs, and we're going to learn about stars, you know. See that bright thing up there in the sky? Oh, that is really bright. We're learning about it today. So, one of the first things I'm going to tell you all about these stars, and we'll probably keep this out, is an important thing. Is that if you ever see a star, do not go close to it, because stars, even though they might look good, they're good for lots of things. The sun gives us life, or light, so we can have life. But, you know, the sun also can take it away just as easily, so remember that. It will one day, but, you know, we'll all be dead then. But one of the important things to remember is that if you ever see a star in nature, you never go towards it, because all stars, just like the song about Shrek, all stars, they are radioactive, which is bad. So you don't want to touch a star if you go see it in the wild. Now, what is a star? It's a giant ball of gas. Well, it's really plasma, but the plasma is on fire. Now, what elements are mostly in them? Well, let's talk about our sun first. This tape sucks, man. I think it's a tape company or something. So let's represent a table of our sun. Those two abundant gases in the sun are hydrogen and helium. Following that, you have oxygen and carbon. You also have some elements such as neon, nitrogen, and magnesium. And the last two that no one ever cares about, iron and silicon. These are the elements that make up our sun and most other stars. So, bam, bam. There. Now, the way the sun works is that it burns. All stars, they take the hydrogen gas and stuff that's inside, and they burn it. So, you just wait right there. They bring a fire. They burn it, and it makes light. This sort of light, you know. That's not a very good flashlight. Now, when they do it, it releases energy. And also, hydrogen is a very magnetic thing. It is a magnetic element. So is iron, but we're talking about the... You know what, why not? I will add it on iron too, because iron's like the most magnetic thing. Maybe more of these. I'm gonna guess magnesium is too. I don't really know. But I'll stop there for now. So everyone knows what a magnetic field is, right? Yeah, it's the giant ball of magnets that surround the Earth. I'm kidding. It's a field that surrounds the Earth. Now, I'll get to other things, but the sun has magnetic fields too. It has a lot of them actually, because of hydrogen. Here's the thing though, they can get crisscrossed, and they go all over like a rubber band, and when you get a rubber band crossed over so many times, it snaps, like it just did right there. And that's what happens with the sun. It gets tangled up, and then suddenly a burst of like fire will come out of it. That's what we call a coronal arc. Not like, sort of like the beer actually. But, So you get the sun, and it's got all these magnetic fields. They're like this, but when they start going in different directions, then you'll get like this loop that comes out of the sun. And the loop will get bigger and bigger, just like Pop the Pig, and then eventually it pops like this, and then all the stuff comes hurtling into the space. It's called a solar flare. And what does a solar flare do, you ask? A solar flare, if it goes towards Earth, don't worry, you won't die, but something important will. Let me just draw a quick Earth right there. There's Africa. Alright, if it hits Earth, Earth will not really, it might get a little hotter, but the real effects is that there will be no technology available because it will knock all that out, so no computers, and the satellites also will not only be knocked down, but they will fall to the ground because they'll go out. That's what the solar flare will do for them. And solar flares come out of these areas called sunspots. It's like a darker, cooler area on the sun that's about the size of like 13-ish Earths right there. So, they're big. And once you get two of them getting close to each other, one of them will make a loop, the arc, and it'll get bigger, bigger, and bigger, and then it'll break, and all this stuff comes out, like I said. And the sun will repeat this process. The other thing is the sun burns its fuel, it gets bigger and hotter. And so, you talk about the death of the sun. It's going to be like this. That's where it started. Here's where it is today. And here's where it will be when it dies. Let me just show you where Earth is in that. Right out there. There's Venus. And here's Mercury. That's how big the sun will get. Now don't worry, we'll all be dead then, but still. That's what the sun will do. Now all stars do die, but all stars get born too. How that happens is you got this giant cloud in space, and all the stuff starts falling to the center. And it gets pushed in on each other, it gets hotter and hotter until it gets a flame. And then that's basically it starts a star. Once one spark is made, it'll go, just a big fume sort of thing. There you go. That's that. Now, another important thing to remember about stars is that the smaller ones last longer. Like, think about this: fat people in races, they are bigger and they don't last as long because they're fatter and they get tired easily. But the smaller guys that are skinnier, they can go for a longer time because they don't have as much body fat slowing down. I mean, this may not be the best analogy, but just remember, the bigger ones blow up first. The smaller ones never blow up. They just sort of fade away once they're done. So the sun, when it dies, it'll get really big, and then it'll just shrink. It'll shrink down to a really small size, and it's called a white dwarf. But bigger ones, like, let me just show you, some stars, this represents our sun. This represents Alpha Centauri. This represents Sirius A. Stars get bigger. Earth around this, well, let me show you. This would be Jupiter, just about. This little loop right here. This is Jupiter, that little loop. Not the whole around, just that little loop I'm making. So you compare Jupiter to the big ones, you get what I'm saying. Earth would be, I guess, in the size comparison, about the size of the no, that's actually too big. Be about the size of, I would say, smaller than the tip of that pen. Well, let's go with it. But our sun's a medium-sized star. It's basically just going to grow to about this size, and then it'll be done. It'll just be done. Stars about this size typically will go supernova. They'll go big explosion. Once about this size, they will become a neutron star, which is really just something about this size that is really heavy and magnetic, and you don't want to get near it because they shoot light beams and stuff, that radioactive energy. Now, I couldn't find a ball big enough, but one's about this big will turn into black holes. And I've already explained how that works. You see, make a hole in space when you push down, sort of thing. But yeah, here's the point: is stars have fuel to burn, and once that fuel is done, I'll just let that burn, yes. But once all the fuel's out, it only has so much. So, I guess we'll just sit here and watch this. Light and energy, once it's all burned out, it's all burned out. So we'll say this is a star. This is about where the sun is in its life, about halfway through. I don't think that's even going to finish burning, to be honest. Well, it's going to stop right there, but still. Oh. Alright, I'll finish this episode quick, because... Yeah, smell of this. Well, now remember, important elements. Stars die, become black holes, you know, that sort of thing. They sort of fade away, that's what the sun will do. Can't really think of that much else to say. Don't look at the sun, you will go blind. Why are you pointing down, camera guy? Whatever, don't try this at home. We good there? How long was this video? Too long? I don't know. Don't try this at home.